morning, good afternoon, good evening from participants from all over the world. Today we are going to have a session on 360-degree view of Azure Security. The speaker of the day is DEBASIS PATI. He is an enterprise architect at top Fortune 500. So moving to fifth IR. Fifth IR stands for your transit towards fifth industrial revolution. It have over hundreds and thousands of strong community of technologists from all over the world. We deal with consultations and projects on multi-cloud strategy, data science, and AI, blockchain, and extreme engineering. We also help technologists to share their learning and get opportunities through our partners worldwide. So this is a short infographic of how we are growing. We have offered 1,000+ sessions and we have 300+ speakers associated with our platform, and we have 27,000+ members associated with our platform. These are the few MEPs and master members of our platform. How we can help you? We can help you to build your knowledge, digital presence, and help you in odd hours when you are looking for a job through our community. All you can access through our link www.fifthir.com. Fifth IR stands for Transit Towards Fifth Industrial Revolution. As a part of our community, we are going to provide free participation certificate for all the participants. You can access the certificate by providing the secret code, and the secret code will be given at the end of the session. This is a sample certificate which you can get at the end of the session, and you can share the certificates directly from the private dashboard to Facebook or in any other social media platform. Now about the speaker of the day, it is DEBASIS PATI. He is an enterprise architect at top Fortune 500. He has been associated with different roles in the organization, such as product, technical architect, and IT consultant. He has got certification both from Microsoft as well as AWS. He is an AWS certified solution architect associate and SysOps administrator associate. He has got he is an Azure administrator associate from Microsoft. He has got Azure architect certification from Microsoft, and he is a DevOps engineer expert certification from Microsoft. You can see more about him in the given LinkedIn profile. Now, over to DEBASIS.
Yeah, thanks, Gavaskar. Let me share my screen. Good morning, good evening, good afternoon to the entire audience. And my name is DEBASIS PATI. Gavaskar already explained. I'm working as a public cloud enterprise architect now outside India. And I have a vast amount of experience in terms of public cloud technologies, as well as in the enterprise area. And today I will be speaking more on a Azure security perspective, and that's a 360-degree view of Azure security. This is a very vast topic, actually, if I say, but here what I will try to explain is some fundamental concepts, as well as I try to touch upon the various area that falls into picture, actually. So let's see how it goes. Yeah. So why security is important in public cloud platform? It's because it's always stays outside your organization boundary. Okay, so things are getting managed or getting utilized outside your organization boundary, and that is where we have to ensure that it is secured from an end-to-end perspective, and that is where security is a very important aspect in public cloud platform. And it ensures that your platform applications, users, whoever are the stakeholder of the public cloud platform, they are actually running securely, and basically a practice that tells all of the stakeholder where they are responsible for what, basically. So that is what all about Azure security, or the public cloud security, you can say. And Now here I am trying to cover more the Azure part. Basically, it's a part of Microsoft, and I have also shared a link from Microsoft site where actually, if you want to learn more about those things, you can always refer to this Microsoft site and start getting into the fundamentals of how it works. Now, basically, if you see from a 20,000 feet view, then there are predominantly six functional building block or technical building block, whatever you can say, are covered in Azure Security boundary, and those are application storage, networks, operations, compute, and identity. So in this session, we'll try to go through one by one, more on a high level. I try to cover as much as possible, and we'll try to understand, the practices behind it, basically. Now, to start with, this is very common for any public cloud platform, basically, be it Azure, AWS, or whatever other public cloud technologies. There is always a security responsibility matrix that gets defined by the from the end-to-end chain, basically. So when I say what is end-to-end chain, because here when the organization or the user is actually using a public cloud platform, then there are two important stakeholders that plays an important role. Is the public cloud vendor, who is actually providing you the data center or the different technologies behind the public cloud, and the customer itself. Okay, so they are the predominantly, they are the major stakeholder of in this boundary, basically. Okay, now if you try to divide the whole organizational landscape, then you have different building blocks, and those are like information and data devices, whatever instruments, or the laptops, or desktops, whatever servers you are using. And then accounts and identities, this is more about who you are, I mean, how you are aligned to different identity within an organization. Then next is who is managing those identity. Applications, are the applications or the workloads that those are running on the public cloud platform. Then what are the network controls, that is more about how the intercommunication or outer communication is happening from and to your cloud platform. And then operating system is more about what kind of OS, all these things you are using in terms of different capability within public cloud. Physical host is more a IS kind of a topology, where the VMs and other database, all these things you are using. And then physical network and physical data center. So these are the important building blocks that we consider in security fundamental. And if you see again, from a fundamental perspective, public cloud is again divided into different paradigms. For example, SaaS, software as a service, platform as a service, infra as a service, and obviously you as an organization, you have an on-prem model as well. So these are the four dimensions where this 8 or 9 building blocks plays a role in terms of responsibility. And the dark blue is more about a customer responsibility or a user responsibility, and the light blue is more about a vendor's responsibility. Vendor means who is actually providing you the public cloud technologies. He or she, I mean, it is the vendor. And shared responsibility, where you both play equal important role, actually. So that is the shared responsibility. For example, let's say if you consider applications. Okay, so applications, based on their different pattern, basically, or their different compute capability, based on that you can go for a PaaS platform or a IaaS platform, or it's a complete on-prem platform. Okay, so in that case, for example, if you're using a SaaS platform, for example, the best example is like Azure Databricks is one of the best service in data engineering space. So that's a kind of a SaaS platform. Okay, where it's a managed platform, both from Microsoft and from a different vendor, Databricks. Okay, so that is kind of a SaaS platform, and that is all is a, for example, Microsoft responsibility or the public cloud vendor responsibility. When it pass, for example, if you have already worked in Azure, Azure App Service is a PaaS platform. Okay, so what is an Azure App Service? Azure App Service is a compute capability where you can deploy your web applications, for example. Okay, so now here how the responsibility lies is the application is the responsibility of the user or the customer, and whereas the platform that is running underneath that is a, or the PaaS capability, which is an app service with a plan, or the whole ecosystem of app service is the cloud vendor's responsibility. So it means it's a shared responsibility. Okay, let's say the same application, for say due to some other reasons, you are deploying in a IaaS kind of environment. So it's a purely a VM based area. Okay, where the entire stuff, starting from the OS management to the VM management to the application management, the whole end-to-end chain is a consumer's responsibility or the user's responsibility. So that is how it gets segregated. Okay, for example, if I'm talking about physical network, it's all the cloud, cloud provider's responsibility, be it SaaS, PaaS, or IaaS. But if it is shifted to a on-prem kind of a data center, it's off-prem, you can say, it's non-public, not a public cloud environment, then it's a customer responsibility. So that is how you can segregate. You can go to this specific site and you can have this metrics depicted in Microsoft, and you can just try to map your knowledge or idea that where you are working on and how the responsibility will line based on different building blocks. So that is just a nutshell how the responsibility matrix looks like. There is a similar responsibility matrix also defines on AWS architecture framework, which also you can refer. Now, out of that 6 building block that what we discussed, let's start first with application security. Okay. Now let's first define what is an application. So applications are nothing but the use cases that you are building. Okay, so it can be a middleware application, it can be a web application, it can be a backend service application. So you can categorize in any sense, and those are application basically. Okay, that caters to fulfill your business functionality. So that is your application. Now, when the application is running in a platform, wherever actually it can be a on-prem platform, it can be an off-prem platform. So that is where you have to take care of a lot of security aspects. Okay, so in that context, actually, when I'm talking about public cloud, actually, so there are certain responsibility that is lying within public cloud and also with the user to design their application. Okay, so I will go one by one as an example. Like the first, let's start with WAP. So what is WAP? WAP is a web application firewall. Okay, now what it does basically, so it's actually prevents you to do different kind of attacks from outside. Okay, in a nutshell or in a layman's sense, if you try to define what is an WAP is a component that sits wherever you can. Here it is in application gateway, but WAP is a independent component that can prevent your application to prevent any SQL injection or XSS attack or any other kind of custom attacks basically. So that is how you can define. Now uh, how it works. Okay, so first of all, WAP is based on OWASP blueprint basically, and you can define your own rule set in a WAP component. Okay, own rule set in the sense, for example, I'm just giving a very good example that when you are getting requests from certain range of IPs outside your organization, that is a topic to be investigated, for example. Okay, so that is where you can create a custom rules within WAP, and then you can define it, that kind of a criteria. Apart from XSS, SQL injection, those are all very generic attacks. That is very generic, but you can also define your specific rules within the WAP component. Now, how it looks like in an application landscape. So if you go back to any public cloud vendor, here it is Azure, then it is always your backend applications or services are front-ending from an application gateway. Okay, so what application gateway is, it has its different capability. For example, application routing, load balancing, all these things are there in application gateway. So this WAP component in Azure, it's attached to an application gateway. Okay, so what it means, be it a external consumer or an internal consumer, when there is a request coming to your backend applications or your application, then it always get filter in the application gateway level using WAF. Okay, and in that WAF you have certain rules defined, and that WAF will be responsible to scan those requests based on certain parameters, and that WAF will responsible whether that request will go forward or not to your backend systems. So that is how it works. And when you have a WAF, then you are actually kind of giving the responsibility of all this kind of NFR functionality within that component, instead of the backend application will hand those. Okay, so that is where you can also segregate your responsibility using web application firewall. Now coming to app service auth authorization, it is very it's very it's a very normal topic actually, and you can design it in your own way. Okay, so in a nutshell, it is a proxy pattern or a reverse proxy pattern where you can have your all security related authentication authorization can be kept here. Okay, instead of application. For example, if you go to app service within Microsoft Azure, then there is a built-in capability available, is easy auth middleware that will be responsible to authenticate you whether you are a correct user or not to access the downstream application. So here the downstream application is a web application, for example, let's say, and then in this particular simple example, let's say user is actually accessing to a front-end page, and that front-end page will trigger you to go to a web application. So here, if you have this easy auth middleware, then you can validate the user from an identity provider basically, and that with that response of the identity provider, you can further validate whether it's a right user or not to access these web applications. Okay, so this is inbuilt capability, but this can also be designed as a out of box capability. Okay, in different scenario. So this is what you can have a practice in terms of segregating the roles into a different component when you are talking to your downstream application, and then you can have your own logic to authorize that user, maybe with different identity provider, like Azure AD is the native provider, but you can use Facebook also to have that identity validated, and then you can provide different access. Okay, so that is about auth authorization. And then again, coming to layered security, it's layered security is more on the platform level from the application level. For example, I've already given you an example, like if you are running an application in an app service, which is a PaaS component, then what happens is there are different way you can deploy an application. Okay, so there are different plan associated with an app service. For example, app service environment. App service environment is, it provides a dedicated network capability where the app service can be injected inside. Okay, so I will also cover this in details in network sections as a part of building block, but just to make you understand that this, if you see the left hand diagram, then your app service is injected within your own network. Okay, and within that network you have a subnet, and that subnet have different network security groups rules basically. So that will decide who can access to that app service or who cannot access, and to where that what that app service also can access to the from the internal world to the outside world. So that you can configure within that network boundary. Okay, so that is a layered architecture. So even if you have different security checkpoints within your applications, like we discussed, the application security where auth authorizations are still there, but you can still have a scope where you can have a network level security also here. So that's kind of a layered architecture. Okay. Now in the right side diagram, so there is also a different plan available in app service, is a regional integrated scenario where your app service is an integrated scenario rather than the injected one we discussed. So in that case, you also ensure that your app service is getting accessed from a private network using private endpoints, and then for the outbound request you are going via a private network. So that is where actually you are ensuring that all the incoming requests and outgoing requests to your applications within app service are getting filtered in different network level. Okay, so that is a layer security. Now coming to diagnostics, diagnostics is more about telemetry data. So basically what is happening within your applications, okay, that can be traced back basically, okay, be from a request perspective or a utilization perspective, all these things. So if you same example, if you use an app service, then there is a diagnostic settings available within app service where you can segregate your application log, platform log, security logs, whatever you want, to different log storage mechanism. Okay, so that is what the role of diagnostics. There are very advanced diagnostics as well possible in PaaS services, where you can have the complete chain of how the service is operating. So basically um, s- all integrated systems, what is happening, you can still deep dive into different parameters of the request, parameters of the platforms, all these things from a application map capability also in this as a part of this. So that is all about diagnostics, and diagnostics is also applicable for different other services within Azure. Okay, so this kind of a similar setup you can do with the EAS infrastructure as well. It can have a SaaS infrastructure as well. So that is the possibility. So in a nutshell, diagnostics is nothing but end-to-end chain traceability, and to bring out all the telemetry data, what is happening within the application. Okay, so these are the 4 or 5 most important dimension when you are designing your applications on a cloud platform. So that is all about applications. And now coming to the operations. Okay, so operations are what you are doing, in and out on a daily basis to maintain your applications within a public cloud platform. So that is the operations in a nutshell. Okay, now the how it is divided from on a security aspect is, let's discuss the most important service that we use in Azure is Sentinel. Okay, so what it does, it's a managed service from Microsoft Azure, and that deals with the security intelligence or security analytics within the platform. And based on that, it can also do different orchestration automation. Okay, so I will give you an example how it looks like. Now, the basic important thing what Sentinel does is 4 things: attack detection. Okay, so attack detection in terms of what kind of attack is happening to your platform. Okay, threat visibility, then proactive hunting. So it is more about an intelligence to find out what is happening. Okay, in an intelligent way, and based on that particular event, response mechanism. So that is, these are the life cycle, you can say, of Sentinel. Now the functionality, how you can define is the 4 functionality. Okay, collect is what across you have a cloud platform, and within that you have lots of devices, lots of users, lots of applications running. Okay, now collect is nothing but collecting data across the cloud platform, irrespective of device, user, application, all these things. So it can collect all the data, and then it can detect some unwanted event. Okay, so that's a kind of a proactive hunting, you can say, where it can detect. Okay, and then after detect, it can also investigate. Okay, what is happening. Okay, so for example, let's say there is a particular traffic that is coming to an applications on millions times, or from a specific IP. Okay, so that is the investigate why it is coming, how, what kind of frequency it is coming, and based on the investigate, then it orchestrate to that particular event what needs to be done to mitigate that event. So that is how you can define the functionality of a Sentinel. Now, how it works actually, I mean, on the bottom line, how it works. So there are different data collection connectors are available within Microsoft Azure, and those are again divided into two categories. One is a Microsoft oriented connector, and then non-Microsoft based connector. Okay, so for Microsoft oriented connector, which is service to service connector, is the important one is 365 Defender connector, and that is basically responsible to integrate your data from different other area like 365 Office, Azure Active Directory, all those things. From there, it can pull all your data to that particular area basically to investigate, response, all these things. And for the non-Microsoft kind of integration, it's basically it tries to get the CF data, which is common event format data. Okay, using REST API, it can connect to data sources with Microsoft Sentinel. Okay, so that is how it works, and that also works in an agent kind of a installation where you can have a Sentinel agent sitting, let's say in a VM, let's say VM use case, and which is actually the log analytics agent, and that it is responsible to convert the common format into a log analytics kind of a format for the ingestion purpose. Okay, so that is very high level how it works, and how you can enable a data connector within that area. That if you go to the Azure portal, in the left pane you can have different kind of connectors, but before you start using the connector, you have to fill or you have to do some prerequisites. It's more informational, you can easily get through, and then once that is done, then you can define your analytics algos or queries to work on that data. Okay, so that is how it works. Now this is more about how you can have a REST API integrations and agent integrations, basically Sentinel, but I am not going very detailed into that, so let's keep that. But in a nutshell, that is the work of Sentinel, where it can integrate MSFT or non-MSFT related data. It can pull those data, and then it can transform it, and then you can push it to any downstream services. Okay, or it can also orchestrate based on the detection with its own analytical capability. Okay, so that is how it works. Now, the Defender is again an operational activity because we are discussing operational block, so operational activity, and this is also a DevSecOps practice. So I don't know. I mean, probably if you all are aware of what is a DevSecOps practice. So DevSecOps practice again deal with the two boundaries. One is the CI boundary and the CD boundary. Okay, so CI is nothing but building your applications, and CD is deployer after the building. So that is where it follows that security practices basically. So this Defender is again a managed cloud native application from Azure, and then it enables you to do security management both at code level and the cloud level across. I mean, it also enables you to do the same practice in different other vendor cloud platform as well. Okay, and then you can always have a graphical representations of a 360-degree visibility of your security view of your environment, where you can have different kind of metrics defined. Okay, it's a DevOps metrics or platform metrics, all these things. For example, these vulnerabilities also you can find, and based on that you can have some recommendation as well to correct yourself. Okay, so that is how it works. It can also categorize the type of vulnerabilities like high, medium, and low. All these things you can do using this Defender capability. Now again, application insight is an extension of Azure Monitor. I already explained in the application diagnostics area that you can get the end-to-end view of an application health basically, and that is application insight is an extension of Azure Monitor. It's in service again. Okay, within Azure, it's a PaaS service, and then it provides at any point of time, it provides you a overall health view of application running in the platform. So it also comes in operation, because as an operation engineer, you have to also get this data, okay, more often to ensure that your things are working fine or not. Okay, so what it does, it stores application log data, okay, and based on that application log data, it can create different metrics, okay, for the traceability that it does. And how you can use that, you can do it programmatically using SDK within your code. You can also go to Azure portal to have it, enable for your services. And then once that is done, then you can have different query to get the platform metrics or whatever application metrics into that. Okay, application map I have already explained you. Sorry. Yeah, application map I have already explained you that even after getting the insight, you can even go into the deeper dive of those application data in terms of what is happening on the integration layer, what is happening on the request level, more deep dive into that, error level, all these things you can do using application map. Azure Monitor, again, the same thing. It works on top of activity log on subscription. So in Azure, it is more subscription to resource group to services. That is how the hierarchy works. And everyone has an activity recorded on the subscription level. For example, what is happening in terms of deployment, which service is calling to what, all these things that gets recorded on that level. And Monitor works on that particular data, basically on top of the data, so on activity log. Okay, it always give you a end-to-end view of the overall health of that particular subscription and RG and services that is in behind it. And you can also create different event and alerts based on something. For example, simple example, your CPU is going 80% high, you can always create an alerts based on that particular threshold value. Okay, so that also you can do using Azure Monitor. Also scaling scale out capability with that particular utilization, you want to scale it or scale down based on some metrics, that also you can do. And it also can be used to perform the security event, that what we discussed in Sentinel also, that can be integrated into log analytics, which is a part of Azure Monitor. Now, Azure Advisor is best the recommendation part. So something is happening within your platform, and based on that happening, you can advise something. Okay, so for example, let's say there is a less utilization of something going on, so it can be advised to either use that machine or delete them, those kind of things based on the telemetry data. So it's a recommendation based on the telemetry data. Okay, now how it will help you? It help you to enhance your performance, security, reliability, all those cloud dimension. That so the advisor helps you on those perspective actually. Okay, so that is all about operations. Operation is, again, it's a day-to-day activity that what we do on top of a platform. Okay, now coming to Azure storage, it's a very important service within Azure cloud. And coming to SaaS is an important topic, is shared access signature. So what it does, it provides a access to the consumer. Okay, so what they can do in the storage account. So storage account is nothing but where you can keep your data, basically, in terms of file, objects, whatever. Okay, now what SaaS deals with, it deals with three important aspects. That it decide which content of the storage to be accessed, it decide what permission to be provided to the consumer who is actually trying to access that, and then how long it will be provided. Okay, so that these are the three important parameters it covers actually. Now types of SaaS is first, the one is user delegation. Okay, so but user delegation is only applicable for blob storage and ADLS Gen 2. So ADLS Gen 2 is, again, is a flavor of Azure storage. Blob is also a flavor of Azure storage. And when it works actually from a lifecycle perspective, it is driven by Azure Active Directory from an identity perspective and from a RBAC also. Now, how that delegation work? So if you see the steps, basically there are 4 or 5 steps involved. Now to make it works, you first need a delegation key. Okay, so how you will get a delegation key, and who can get a delegation key? So if you see from a Azure perspective, it can be an user, it can be a application, or a technical user, you can say, in a sense. So now, first of all, you have to decide that who can get that delegation key, and to get that delegation key, what kind of privilege is required to have it. Okay, so these are the first 2 important steps that you need to define. Okay, so here, for example, service principal also is a technical identity, that is, let's say that it's trying to access a storage account. Okay, so first the service principal will first get the delegation key, and for that what kind of RBAC permission is required. Okay, now with that RBAC permission assigned to that particular identity, it will talk to Azure Active Directory here. Okay, to get that particular OAuth token. Okay, which is required to get that particular delegation key to the end consumer. Okay, so once that OAuth token is obtained, then with that OAuth token, that service principal, technical user, or any user can get the delegation key. And once the delegation key is there with these 3-4 steps, then with that delegation key, delegation key can be used to create a SaaS token. Okay, so that is the SaaS, shared access signature token, and that particular token also can be assigned different RBAC permission to do certain operation on that storage account. Okay, so this is little bit complicated. Here 2 things are happening. Who can get the delegation key? It needs RBAC permission to get the delegation key. One, that key is obtained. Okay, that delegation key can be used for a SaaS token, and once that SaaS token is having the RBAC permissions to do certain things on storage account, then that process completes. So it gets the RBAC and then go to storage account and do whatever it wants. Okay. Now this SaaS is again divided into 2: service SaaS and account SaaS. So service SaaS works only one service at a time. For example, if you go to Azure storage account, there are blob type, table type, queue type, Azure file type. These are different flavors available within Azure storage account. But when you are using a service specific type SaaS, then within your operation, either it's a programmatic connectivity from your client to the storage account or whatever you are doing. In that operation, you can only use one service at a time. For example, you can only connect blob or table or queue or Azure files at a time. But when you are using an account SaaS, then you have a provision to access any service at one go. So that is the difference between service SaaS and account SaaS. But there is fundamentally same in behind. Now, data encryption, I mean, that is the most fundamental topic in cloud basically. But data encryption again divides in 2 parts. One is data at transit, and another is data at rest. Okay. Now, in the transit means when it is traversing from one system to another system, the data is flowing. Okay, so that is the transit case. Okay. Now, fundamentally, you have to use HTTPS for the first level of security on the where level. Okay, that is one. Then for the file share, which is a very special case, your file transfer, is use the SMB, server message block kind of a techniques. Okay, and then to have another layer of security, you can also at the client side or the consumer side, you can encrypt the data so that that encrypted data can be transmitted on the wire. Okay, so that is how you can handle the transit encryption. Now coming to encryption at a rest, it's server-side encryption, mostly in Azure kind of a topology. It's a customer managed key, CMK, or HSM, which is a user-defined key. So that those are the things that is used actually just to ensure that whatever data you are keeping within the cloud storage, that should be encrypted in nature. Okay, and that should not be compromised. Now all these key management, okay, that can be done with a proper secret management kind of a design. Okay, so those so for example, a CMK, okay, customer managed key is nothing but a key where you need to keep that key using a proper secret management. Okay, for example, in Azure you can have a keyword set for do this for doing the secret management. In AWS you can have secret manager. Okay, so that is more design choice. Now coming to CORS. CORS stands for cross origin resource sharing. So when you are actually working on a storage account, it's nothing but a service, HTTP service again at the end. So CORS decide who can access that. So it's more a domain level communication. So which consumer domain can access this particular storage, that you can decide or you can set enable from a cross origin resource sharing. Okay, so fundamentally it's a header based approach to identify a specific domain that is coming to your domain to access the data, and based on the request, basically you can define programmatically or from Azure portal that what the consumer can touch, can do basically on top of that storage, and then based on the first request it will be response back with certain set of activities it can perform on the storage. For example, here you are allowing the consumer to have get ahead options. Okay, so it can retrieve some data, it can do some update operations as well. So that kind of things you can very well compose or define within this area basically. Yeah, so that is about storage. Network thingy, I have already spoken a little bit on that, but again, let's start. This is also an important area, network security. So how it works? So basically, it starts from network access control. And what is a network access control? It defines who all can access a specific network and how. Okay, so whenever you are talking about an application always sits with the network boundary. Okay, be it your own network boundary, be it Microsoft's or the public cloud vendors network boundary. So it works in that sense actually. I mean, it also work with non-network sense, but normally when you are working for some architecture or something, it always works in that sense. So you'll always have a network layer and an application layer in the design. Okay, now what it does, this ensures VMs and service running in a specific network are secure and only accessible to the known stakeholder. Okay, so from a network sense, known stakeholders means you can only allow this request from that IP, XYZ IP. So that kind of a stakeholder. Okay, or you can allow any public traffic to your application. That so public users are the stakeholders. So that is how you guys. Okay, now within that network security, you have network security group. Okay, and this is the basic firewall across a virtual network. So how it looks like within Azure, I have another slide for that. Is it start with a virtual network, and within the virtual network you have different subnets. Okay, subnets is nothing but a IP range basically, and each subnet can have different kind of application. So maybe a front-end application, a back-end application, a database, all these things. So that is how it works, and every subnet is having their own network security group, NSGs. Okay, so that is the first basic firewall where you can say that this particular application can be accessed to this kind of a network. Okay, so that is how it works, and this filters the traffic across two communication parties within the boundaries. That is, I already explained. There is a consumer, there is a provider. Provider sits within a network, and it decide who the consumer that those can access to me. Okay, more on a network layer, and it also limits the traffic flow from network to internet. I have already explained, like you have your private boundary, then there is the internet boundary or the public boundary. So that also you can restrict either to or from, that you can do. This is a sample how the NSG looks like. So the priority is a rule priority. It's a number basically within a network security group. Access is nothing but a rule basically, any user defined rule. Then there is a a source IP, then a source port, then a destination IP and destination port. Okay. So source port, IP means, let's say it's coming from IP XYZP. Okay. And then which port? Let's say it's coming via 443 port. Okay. Now destination where it will go. Okay. So that is how you can define destination is that IP, and again which port, all these things. Coming to Azure Firewall, again, this is also a important service from Azure, and it's a native capability within Azure, and it comes with like application and network specific rules. So application is more about use case wise. For example, you have two applications, application 1 and application 2. Application 1 wants to connect to internet. Application 2, you don't want him to connect to internet. So those are application rule. So this is very specific to your application. Okay. What is network specific rule? It is more generic. For example, let's say I am accessing a SQL database. Okay. So it needs a port 1433. But your organization needs that, and any application can use a SQL database. So 1433 is generic for me. So that can go to network specific rule. So normally in a standard practice or in a network design model, where it falls Azure Firewall is a centralized architecture. Okay. So what it does, it tries to collect all the traffic that is coming from your own applications. Okay. So it's a central area where you can define different rule more on a generic level, also in a specific level. So that is where it falls into picture. It can have an inbound rule, it can have an outbound rule. Okay, so that is how it works. Now again, from a cloud perspective, it is highly available, and it can give you all the traceability metrics. Okay, so now that this is what I was explaining. If this is the central Azure firewall that you can have a hub spoke kind of a architecture where spokes are nothing but your workloads running in your Azure, and then every spoke request is coming out via a Azure firewall. Okay, so that is how it works, and these are the capability: TLS filtering, URL filtering, traceability, all these things we already discussed. This is how the virtual network looks like. I have already explained a little bit about this. So this is a VNet, and then within virtual network you have different subnets. So subnets can have different applications like database, web application, VM, IS kind of application. Those things are there within a network, and within network also you can define like whom should I peer to. So basically it will connect to probably a different network. Okay, maybe your VNet 1 is a web subnet or a backend service that can connect to a VNet 2 where your database is there. So that's kind of a peering. So it can also define routing, where from this VNet 1 where the request should go to. That is the routing mechanism you can define within the virtual network, and also it defines the DNS topology. So these are on a high level. You can have all these things within a virtual network. Okay. Now coming to the private link. Okay, so private link is a capability of Azure PaaS service to connect privately. So when you say it's a PaaS service, it's a public within Azure. Okay, so that is how you can define. So it always gets managed or hosted within the Microsoft boundary. Okay. Now, when you have a workload running in your own boundary, in your own network boundary, then either you can go publicly to access that pass with different other rules, or you want to have a private connectivity between that particular pass service and your workload. So in that case, private link comes into picture, and it is a capability to use Azure pass service privately. It provides a private endpoint for each pass. Okay, that is how it works. So if you see here, I already explained, like the left one is your own network boundary, the right one is the Microsoft boundary, where all the PaaS services are there hosted. And here you can have a private connectivity established between your network to the PaaS network. So that is how you can use it. It is more secured way of connecting between services, actually. Okay, it can also be done in different way, like you can publicly talk to this pass also from internet way or from a service endpoint way also. So there are other techniques also, but the most important is private link, which is more secure. Okay, more from a performance and security perspective. Coming to Express Route provides a dedicated private connectivity from your from the organization network to the Microsoft network, basically. So, for example, let's say you're trying to connect one virtual network to another virtual network within Microsoft, or from a Microsoft services, you want to connect to the on-prem database or something, that kind of a topology, then you don't want your traffic to go publicly. So you can have this achieved by Azure Express Route. Okay, so it's a dedicated connectivity link from your network to Microsoft network, and then normally this kind of a connectivity gets enabled by a different service provider. Okay, so basically, if you see the diagram, the user network is your network, and then there should be a partner as a network that have the capability to connect to the Microsoft network privately, basically. So that is how it works. So you have another partner service provider come into picture. It has a dedicated capability to connect to Microsoft Edge, and then from there it can again connect privately to different network or PaaS services. For example, private link and those kind of things. So in AWS, it's a direct connect. Here it is Express Route actually. So the same fundamentally same kind of. Yeah, so that is all about network. And now the last topic, we have almost discussed this also in our in across our 5 topics, is Azure Compute. So now coming to, these are very generic. Anti-malware, antivirus is used especially for IS workload, basically. So it's a real-time service within Azure that helps you to removing any virus that is coming to your machine, do a regular scan, take action against malware. I mean, what normally your antivirus does, basically. And in Azure IS, you can use different software like Symantec, Trend Micro, all these things. Okay, so this is the capability within Compute Azure. Now backups are just to ensure that you're protecting your data with the minimal operational impact. This is a normal procedures when you are working with a very critical workload. And what you can do with a backup service, Azure backup service, you can have VM backups, you can have disk backups. Disk is always attached to a VM. You can have the storage backups like file share. Okay, all these are just example. DB backups, blob, all these things that you can do with Azure backups. Then coming to site recovery. So site recovery is predominantly for disaster recovery and business continuity plan to keep your workload running actually. And then again, site recovery, there are different fundamentals like regional replications, journal replication, all these things come into picture. And it operates with different techniques like MEC, Microsoft XLS compute, with replication between the edge compute and all these things. So these are the different fundamental actually. So what basically it does fundamentally is helps to run your workload in a secondary location or a secondary data center, you can say. Always provides a fallback scenario and ensure that your data is safe. So that is the site recovery. So it is also an operational practice to have this done basically based on your workload requirement. Page updates, it's again, if you go to the responsibility metrics for IS workload, it's a consumer responsibility or the user responsibility page updates, and this deals with finding and fixing security problems within the machine's operating systems. And it also simplify the update management process. That is, but who will do that? The user will do. Okay, it can be an automation, but it's the responsibility lying with this. Now it helps in reducing the number of software updates, organization, and monitoring compliance. That's a requirement anyway. Defender we have already discussed. It's a DevSecOps practice, again applicable for VM kind of a compute kind of a workloads, and we have already discussed that it has DevSecOps practice solution, security management at code level, and then cloud security posture management, that solution that deals with action to prevent security breaches, and then the CWPP that with specific protections for servers, container storage, and database. So these are the high level information about MSFT Defender. Yeah, so this is what I want to cover. Actually, it's a very big, huge topic, but I tried my best to just give you a flavor, at least in basic aspects of Azure securities on different building blocks. Yeah, that's it. That's it from my side.
Yeah. Participants, any doubt, any questions? You can ask. You are on unmute. You can unmute yourself and you can ask your questions. So there are the buses. I think it has been a wonderful session. It's a big topic actually.
Yeah.
There is within 1 hour. No, you have given crispy things. No, you have given. So I think it's a wonderful session. I think the audience may enjoy the session. So audience, the speaker code for downloading the certificate is shared in the chat. You can click the link and you can access the certificate by providing the speaker code which is provided over there. So on behalf of Multi-Cloud for You, we like to thank Debashish for providing a wonderful session on 360 degree view of security, Azure security. Okay, thank you participants for the session. Thank you.
Thank you guys. Thank you. Bye.